This taxi geometry problem once again compares several different ways of thinking about distances and centrality. And again, the goal is to develop ways to visualize several different kinds of distances, centers, and spread. In particular, you'll again be investigating the location of a point P which best fits a collection of data. However, in taxi geometry, the distance from P to other points is not measured along a straight line path. Instead, distances are measured along L-shaped paths that involve only right turns. In this taxi geometry worksheet, you can move the points A through E to any locations that you please. And, in each case, you can move the point P until it minimizes the sum of the distances to the other points. Do this several times for taxi geometry distances, until you have figured out a pattern or rule that allows you to quickly find the point of best fit, which, in this case, also can be called the least distance point. Once you know a quick way to find least distance points in taxi geometry, compare this point to the least distance point that is based on usual straight line distances. Investigate whether the locations are the same for these two ways of finding a least distance point. Then, investigate the location of the point that minimizes the sum of the squares of the paths. In particular, investigate whether the locations are the same for these two ways of finding least squares points. To explain things to yourself, you may find it useful to notice how the Pythagorean theorem applies to taxi distances and straight line distances, as well as to sums of squares associated with these distances.